Hello, friends. Welcome to the ATC Double Cut. I'm glad to be back recording a show. It has been a while. I looked at what I've recorded or when I posted the last ATC Double Cut, and I see I didn't do anything in July. So I've been pretty busy. I think many of you know I went to the International Turfgrass Research Conference, which is held every 4 years. And this year it was in Karuizawa in Japan. So I took a business trip to Japan and I went to that conference, which was great fun. And I met many of my scientific colleagues from around the world. And it's interesting at scientific conferences, when we meet people in the hallway, a common question is, or a common conversation is, what are you working on? How's it going? How's your research going? And I thought, I've been working on all kinds of really interesting things. I've been doing a lot of really fun stuff, and I've been writing and preparing presentations, and I've been reading and doing research, and my research is going, I'm very excited about the stuff I've been working on. And I've shared some of that on the ATC blog, and there's more coming up. I can't go into too much detail because I realize if I say everything that I plan to do and say everything that I've been working on and then put, how does that work? I'm like saying that I'm going to do something, it puts some pressure on me to actually accomplish it. So when it comes to research and writing outputs, I try not to talk about it too much until it's already done. And one of the things that I've been working on is in a blog post called median sand diameter. And that's one that I published today. And this will be a short one. I just want to talk with you about that because it's a number that I haven't heard too much, but I think that this is an interesting number to consider because turfgrass managers on golf courses or on athletic fields, anybody managing high performance turf is probably dealing with sand in some way. And that may be a sand root zone, or it may be a sand top dressing material. And when people are working with sands, it can be interesting to compare the sands because you generally have some options. Maybe you want to know how this sand compares to the place where you worked previously. Maybe you want to know of the 3 potential top dressing sands that you could use, which is finer, which is coarser. But when you start looking at the USGA recommendations for putting green construction, which is a standard guide for sand particle sizes, you find that there are all of these different sieve sizes. So you've got the coarse and the medium and the fine and the very fine, and you have different percentages of sand that needs to be above a certain level at these different sieve sizes. It's not a single number. It's multiple numbers that need to be gotten right. And I've wondered, could we distill this down to a single number? And the short answer is no, we can't distill it down completely to a single number, but we can simplify it in some ways in a way that I don't know that everybody realizes that we can do. So I started off this blog post, which has a title, Median Sand Diameter. I started it off with a picture of some sands from around the world, some from Thailand, Portugal, Japan, Spain, the Canary Islands, Chambers Bay, and a test report from Brookside Labs looking at sand fractions from a typical sand used for root zones on golf courses. So I showed those images to say there's all kinds of different sands. There's all kinds of different sands. Now, what is this median sand diameter? It's a value that is shown in engineering documents or on a technical report as the D50, D sub 50, 50. And what that means, that is the sieve size at which 50% of the sand particles will pass through. I will repeat this. It is the sieve size. So a sieve is something that filters sand, and a big piece of gravel will stay on top and a piece of powdery fine sand will pass through, assuming that the sieve size is smaller than that piece of gravel, and assuming that the hole in the sieve is larger than that piece of powder, then what happens is you have some material that stays on top of the sieve and some of the material passes through. And this is evaluated by mass, by weight. So you'll measure how much of the weight of a sample passes through. Let's say you start off with 100 grams of material, and then you pass 20 grams of it will pass through a particular sieve, and 80 grams remain on top of the sieve. So you would report that that was 20% passing by weight. Well, what the D50 is the sieve size at which you'll have exactly 50% of the sand passes through, and exactly 50% of the sand cannot pass through. And what that means is that's the median particle size of the sand. It's the median diameter of the sand particles in that sample. So that takes it down just to a single number. That's the average size. That's the median particle size of a sand. So I looked at 302 sands, and I put a post on Paste Turf, and that is, I just wanted to check that that's showing on the screen. So you can find this in the Paste Turf photo gallery. And I encourage everyone, sign up for Paste Turf. You can get weekly updates from me. I've also, I guess I haven't been recording podcasts, but I have been doing 3 or 4 updates a week on Paste Turf and doing sharing information through Paste Turf. And I've been writing. I wrote a newsletter last month, so I'll make another plug. If you're not signed up for Paste Turf, I recommend that you become a Paste Turf member. You can get regular updates from me, along with all of the other benefits of Paste Turf. Most people are using it for the site-specific weather updates and growth potential information for their site, and disease risk predictions for their site. But as far as my ATC newsletters go, you can get those at asianturfgrass.com/newsletter. You can sign up, and you can either get every blog post, or you can just get emails from me like 3 or 4 times a year with just the highlights. But that is a good way to keep up with all of the stuff that I'm working on. So if you're not subscribed to Paste Turf, and if you're not getting my newsletters, I will recommend to everybody, please do that, because I'm constantly doing work and sharing new things. And if you're only listening to the podcast, or if you're only seeing what comes across the social media feed, you're not going to be getting everything. And I think the way to get everything is through my websites, because anything that's meaningful, I'm generally going to write about it and share it there. So if we look at the average particle diameter of putting green root zone and top dressing sands, and if we look at that particular chart, which I'm showing for those of you watching, you will see this on the screen right now. For those of you listening, this is definitely a chart that you're going to want to have a look at. So you can see this at Paste Turf, or in the ATC blog post with the title Median Sand Diameter, where I'll put a direct link to that post in the show notes. And if you go there, you can see the chart. So this chart is showing 302 different sands from around the world, and it's showing the D50. It's showing a single calculated value for each of those sands, which is the average particle size. And it's also showing what the USGA fine lower limit is, which is right around 0.3 millimeters. So if you have a sand that is at the absolute finest limit, but it still meets the USGA recommendations, then that is going to have a medium particle diameter of about 0.3 millimeters. If you have a sand that is also meeting the USGA recommendations, but on the coarsest side, at the very coarsest limit, that's going to have a particle size diameter of more than an average particle size diameter of more than 0.7 millimeters. But very few sands, I haven't found one yet that's actually used that has a particle size, an average particle diameter that is that large. And I suppose that has to do with how sands are going to hold water, because there are also recommendations from the USGA that sands have to hold a certain amount of water. And I don't think that sands that are that coarse are likely going to hold enough water. But in general, sands that are that coarse are ugly. We might look at the guidelines and say, okay, this meets the guidelines, but those particle sizes are huge, and it's just like doesn't seem like it's right to grow plant material in it. So what we see in the chart is 85% of the samples are within the USGA recommendations in terms of what the D50 would be for a fine sand or a coarse sand that meets the USGA limits. 85% of the sands are within those limits, and 15% are outside of it, but all 15% of those are on the low side. They're finer. They are the types of materials that people are using either because it's a dune sand, and dune sands sometimes, they often are quite finer than the USGA recommendations, but some of the world's most famous links golf courses are on dune sands that are finer than the USGA recommendations. And they're also the types of sands that people are using deliberately in order to minimize mower pickup or improve the ability of the sand to work its way into a very low cut and very dense turfgrass canopy. So I think it's really cool to be able to just look at this single number and compare the D50 of sand X to the D50 of sand Y. And when we're comparing D50s, we are comparing the average, the median diameter of this sand versus the median diameter of that sand. Now, this is not sufficient to say that this sand is suitable for use or this sand is better than another. The reason why this single number is not suitable is in the tails of the distribution, we could have we wouldn't have a whole bunch of clay, but we could have too much clay, too much silt. Or in the tail of the distribution on the coarse side, we could have handfuls of gravel. And we don't want handfuls of gravel mixed with a very fine sand. So you need to look at the entire particle size distribution. But a lot of sands have, they don't have that clay. They don't have that silt. They don't have the handfuls of gravel. They have very suitable behavior in the tails of the distribution. And in that case, it can be quite useful to look at this D50 value and make an assessment about which sand is finer, which sand is coarser. So this is something that I suppose many of you will find interesting. I hope you do find this interesting. And this is something that you can see all about on the ATC website in the post median sand diameter. You can read about it on the Pace Turf website also, and you can see the chart on either the ATC or the Pace Turf website. So that's something that I'm going to start putting. I'll work it into the ATC OM246 soil test reports. Most of the OM246 tests that ATC does now, the client will request that we go ahead and do a particle size analysis to check what the particle size is at the surface of the green. And sometimes we'll compare that to the top dressing sand particle size and see, as you're adding top dressing or as you're cutting back on top dressing, we'll check how things are changing in the soil profile with the addition or the withholding of different types of sand. So we look at this very carefully, and this is something that I will add into those reports as I continue to make enhancements. You can find information all about that also on the ATC website in the OM246 project page. So if this is something that you have found a sand, I didn't write this in the blog post because I didn't want to ask too many questions in the blog post, but if you listen to this all the way to the end, then you're probably interested in particle size, and you probably know what the particle size is, and maybe you know the D50 of the sands that you're working with. If you've ever seen a sand that's actually used as a turfgrass root zone, let's say putting greens, because I've seen coarser materials used for fairways in Southeast Asia. Maybe I'll look into that and do another blog post about it. But as far as putting green sands, whether they are actual putting green root zones anywhere in the world, or if they are top dressing sands that are used for golf course putting greens, I would be very interested to hear from you if you have any with a D50 that is outside of the range that I showed in this particular chart. And the range that I showed in this particular chart goes from about 0.14 millimeters, something like that, up to about 0.61 millimeters. It's like 0.14 millimeters diameter. That's about half of the median diameter of a sand that just meets the USGA limit, which is 0.3. And then the coarsest material in my data set is just above 0.6. So that's the range that I've seen, and I would be interested. I'm especially interested to hear from you if you've seen sands that are outside of that range in terms of the D50 value. So more of this coming up. We'll continue to talk about this. I have some blog posts that I haven't recorded at ATC Double Cut about yet that are on this topic. So there's certainly more of that coming up in the future. We'll continue talking about this because sand is such an important thing for us in the turfgrass industry. All right. Thanks everyone for listening and for watching. Be sure to sign up for those newsletters. Be sure to get that Pace Turf subscription. And I will sign off now, promising to be back before too long with more interesting turfgrass information. For ATC from Nakhon Si Thammarat in southern Thailand, I'm Michael Woods. Bye-bye.